So the impulse response, the problem is the impulse response of a system is given as ht is equals to tut. The impulse response is given as ht is equals to tut for an input xt that is equals to ut minus 1, that is equals to ut minus 1. The output is, find out the output. So find out the output. So let us discuss this problem. So ht is given, ht is the impulse response. So the just I am recalling, this is your LTI system. Then input is xt and the output is yt. So when your input is del t, the response is called the impulse response, that is inside the system operator we are applying the input xt. So ht is given and xt is also given, that is ut minus 1. Now we can use the Laplace transform and we can find out the solution easily. So the Laplace transform of ht, first find out the Laplace transform of ht. So the Laplace transform of ht is nothing but 1 divided by s square, and the ROC is real part of s greater than 0. So how to get this expression? Please understand that the Laplace transform of ut, the Laplace transform of ut is 1 divided by s, and real part of s is greater than 0, that is the ROC. The reason of convergence is that real part of s greater than 0. So Laplace transform of ut is 1 by s. Now if we multiply with t, then the Laplace transform is equals to it is differentiation in Laplace domain. So it is minus d by ds of 1 by s, and the ROC will remain same. So it will be equals to real part of s greater than 0. So it is equals to the differentiation of this is equals to minus 1 divided by s square. So the ROC is real part of s greater than 0. So it is equals to 1 by s square finally, and the real part of s is greater than 0. So this is ht. This is Laplace inverse, that Laplace transform of ht, that is hs, and it is equals to 1 divided by s square, and the real part of s is greater than 0. So this is what we have written in our previous slide. Please wait, some problem is there. So in this class we will do problems related to Laplace transform for continuous time LTI system. So let us do this problem. The problem is find out the Laplace transform. Find out the Laplace transform. Find out the Laplace transform of xt is equals to cos omega naught t plus phi multiplied by ut. So let us find out the Laplace transform of xt is equals to cos omega naught t plus phi into ut. So it can be written as, so let us solve this problem. So it can be written as ext is equals to cos omega naught t into cos phi cos a cos b minus Sin omega naught t into sin phi into ut, and that is equals to cos omega naught t into cos phi into ut minus sin omega naught t into sin phi into ut. So this is xt. So the Laplace transform of this is written as axs is equals to, if we take that phi t common, if we take that cos phi outside, then it is Laplace transform of cos omega naught t into ut minus sin phi. If we take outside, then it is Laplace transform of sin omega naught t into ut. And all of us know that the Laplace, in previous lecture I told you that the Laplace transform of cos omega naught t is nothing but s divided by s square plus omega naught square, and the Laplace transform of sin omega naught t into ut is written as omega naught divided by s square plus omega naught square. So we can take 1 divided by s square plus omega naught square common. So it is equals to s cos phi minus omega naught sin phi. So that ROC is obviously, it is real part of s greater than 0. The ROC is obviously the real part of s greater than 0. Let us do another problem. So in this problem, find out the Laplace transform xt. Find out the Laplace transform of xt given by, the Laplace transform of xt is given by xt is equals to 1 for t1 is less than or equal to t less than or equal to 2t2, and it is equals to 0 otherwise. It is equals to 0 otherwise. Find out the Laplace transform. So let us solve this problem. First we have xt, that is equals to 1. So basically it is minus infinity to plus infinity, e raised to the power minus xt into minus st into xt into dt. This is the definition of Laplace transform. This is definition of Laplace transform, that is xs, that is the Laplace transform is equals to minus infinity to plus infinity xt raised to the power minus st into dt. Now that xt is a limited signal, xt is limited between t1 and t2, so here that integral will go from t1 to t2. Instead of minus infinity to plus infinity, we are going from t1 to t2. It is time limited signal, and between t1 and t2 the value is 1. The value is 1 for xt. The value is 1 for xt, and it is 1 multiplied by e raised to the power minus st into dt. So it is equals to e raised to the power minus st divided by minus s. It is t1 to t2. Now it is equals to minus 1 divided by s e raised to the power minus st2 minus e raised to the power minus st1. So what we will get finally? We will get it is 1 divided by s e raised to the power minus st1 minus st2. And what is the ROC? What is the ROC? So ROC is basically if there is no convergence issue, so it is all s. So it is all values of s. The ROC is all values of s. So basically it is the entire s. So let us do another problem. So let us find out the Laplace transform. So find out the Laplace transform of ext is equals to minus e raised to the power minus t cos 2t minus 5 e raised to the power minus 2t into ut plus 1 by 2 e raised to the power 2t into u minus t. Find out the Laplace transform of this signal. So let us do this problem. So xt is equals to e raised to the power minus t cos 2t into ut minus 5 e raised to the power minus 2t into ut plus 1 by 2 e raised to the power 2t into u minus t. Now what is the Laplace transform of this is 1 divided by it is basically s plus 1 square divided by s plus 1 square plus 2 square. Please check this, because the Laplace transform of cos 2t into ut, if you find out the Laplace transform of cos 2t into ut, then it is equals to s divided by s square plus 2 square. And if you multiply with it with this e raised to the power minus t term, then it is simply it will produce a shift in s by 1 unit. So it is the Laplace transform of this term minus 5 divided by s plus 2 plus 1 by 2 into what is the Laplace transform of e raised to the power 2t into u minus t. So the Laplace transform of this is 1 divided by 2 or minus 1 divided by s minus 2. And what should be the ROC? So that ROC is minus 1 is less than real part of s less than 2. How this ROC is coming? Please let us check the ROC. Why this RO is coming? So xs, we have written xs is equals to s plus 1 divided by s plus 1 whole square plus 4, and the ROC of this signal is real part of s greater than 0. Second thing is, second signal Laplace transform is 5 divided by s plus 2. So that second signal ROC, that is it is e raised to the power minus 2t into ut. The ROC is nothing but real part of s greater than minus 2. Now the third signal, for the third signal the ROC is the third signal is minus 1 divided by 2, 1 divided by s minus 2. So the ROC of this third signal is nothing but, because it is a left-sided signal, it is a left-sided sequence, so the ROC is real part of s less than 2. Now if we see that if we plot all ROCs on a common axis, like it is sigma, it is j omega. Now this is a real part of s greater than 0. This is first ROC. Please check. Second ROC is real part of s greater than minus 2. So it is minus 2. Second ROC is real part of s greater than minus 2. This is second ROC. The third ROC is real part of s less than 2. So 2 is somewhere at this point. And then this is real part of s is less than 2. So this is the third part. So which one is common? Which one is common? Please see that which one is common. So which one is common ROC? And sorry, I did a mistake. I did a miss some mistake here. Yes. So this ROC is real part of s greater than 1. So this is 1. This is there is 1 here. Let this is 1. And that j omega axis is somewhere here. This is j omega axis. This is 1 only. Okay. So let us draw this figure again. Let us draw this figure again. yes, this ROC is greater than 1 here. Okay, let us draw this figure again so that we will understand better. So drawing figure again. So first is real part of s greater than -1. So this is -1, and second is -2. So -2 is there, -2 is there, and last one is we have 2. We have 2. So what should be the common ROC of this signal? So let us plot the common ROC of this signal. So the first ROC, first signal is real part of s greater than -1. So the real part of s is greater than -1. So this this is greater than -1. Second is real part of s is greater than -2. Real part of s is greater than -2. So greater than -2 means we should go in this direction, greater than -2. And next is the real part of s is less than 2. So this is less than 2, this is less than 2. So which one is common part? So the ROC should be between two real part of s to 2. So that ROC should be between these two. Okay, so let us do another problem. Let us do another problem. So the problem is let us do another problem. Okay, sorry. Okay, this. So the problem is find out the inverse Laplace transform. Please wait. Find out the inverse Laplace transform. The inverse Laplace transform of xs is equals to 1 divided by s plus 1 whole square, and the ROC is given, that is real part of s greater than 0. So the ROC is provided and the signal is also there. Now second part is xs is equals to 1 divided by s plus 1 whole square, and the ROC is given, that is real part of -1 is less than real part of s is less than 0. C part is xs is equals to 1 divided by s plus 1 whole square, and the ROC is provided, that is real part of s less than -1, and the last part is xs is equals to s divided by s square plus 4 whole square, and the ROC is provided, that is real part of s greater than 0. So this is the ROC. This is the ROC we are getting. So let us solve this problem. Let us solve this problem. So first is xs is given as 1 divided by 2 s plus 1 whole square, and the ROC is given real part of s greater than 0. It is a yes, not 2. Okay, it is 1 divided by s plus 1 whole square. Now this type of problem, first we have to do that analysis by using the real partial fraction. What we have to do, we have to do the partial fraction analysis, and it is equals to a divided by s plus b divided by s plus 1 plus c divided by s plus 1 whole square. Now what is a? So a is s multiplied by xs at s is equal to 0, and what we are getting? We are getting 1 divided by s plus 1 whole square at s is equal to 0, and it is equals to 0 plus 1 whole square, it is equals to 1. Now what is before b we need to find out the c. Please refer the previous lectures. So what is c? C is 1 plus s whole square multiplied by xs at s is equals to minus 1. So it is s plus 1 whole square divide 1 divided by s plus 1 whole square, that is at s is equals to minus 1. So c we are getting is minus 1. Then what is b? Now how to find out the b? So b is equals to d by ds of s plus 1 whole square 1 divided by s plus 1 whole square at s is equals to minus 1. So it is nothing but if we solve this, what we are getting minus 1 divided by s square at s is equals to minus 1. So again we are getting minus 1. So a is equals to 1, b is equals to minus 1, and c is equals to minus 1. Now we need to find out xs. By putting all the values of a, b and c, we get xs, that is equals to 1 divided by s minus 1 divided by s plus 1 minus 1 divided by s plus 1 whole square. So what is xt? So xt is since the real part of s is greater than 0, so what are the poles? We have 0 and 1. So it is basically indicating that since the ROC is, what is the ROC? ROC is real part of s greater than 0. So basically it is indicating the right sided signal. So we have ut minus e raised to the power minus t into ut minus t e raised to the power minus t into ut. Please check this because this problem we have solved, this type of problem we have solved in previous lectures. So we have 1 minus e raised to the power minus t e raised to the power minus t into ut, and that is equals to xt. So let us do the problem B. So the problem B is xs is same. It is 1 divided by s plus 1 whole square, but the ROC is different. The ROC is given minus 1 real part of s is less than 0. So let us concentrate on ROC part. So xs is same. So xs is nothing but 1 divided by s minus 1 divided by s plus 1 minus 1 divided by s plus 1 whole square. So this is xs, and the ROC is minus 1 is less than real part of s less than 0. Now we can see that if we plot the ROC, then we can visualize this problem better. So for better visualization of the problem, we can plot the ROC. So the ROC is minus 1 is, so the ROC is real part of s less than 0 and real part of s is greater than minus 1. These are two conditions. So real part of s less than 0 means this ROC, less than part of s less than 0 means this ROC, and real part of s greater than minus 1 is here we have minus 1, and basically we are talking about this ROC, this part. So this is real part of s greater than minus 1. Now if we see that, then the signal real part of s less than 0 means this is the ROC. If we just find out inverse Laplace transform, then the ROC of this is real part of S less than 0, because that pole is 0, so pole belongs to 0 for this only, this term only. So 1 divided by S means it is which type of signal? It is a left sided signal. It is a left sided signal. So 1 divided by S, so this signal, this means the Laplace transform of this signal. So basically this is a left sided signal. So this is Laplace transform of, this is Laplace transform of left sided signal. And what is that signal? The signal should be u of minus t, because the Laplace transform of u of minus t is equals to 1 by S. Now here we can see that at pole S is equals to minus 1, the real part of S is greater than minus 1. The ROC is given. Now the pole we are getting here is basically it indicates that here we are getting pole of is equals to minus 1. So it indicates that the ROC indicates that this is Laplace transform of right-sided signal. This is Laplace transform of right-sided signal. And what is that signal? So the signal is the e raised to the power minus t into ut. The signal should be e raised to the power minus t into ut. And this is nothing but this is nothing but t into e raised to the power minus t into ut. The Laplace transform of this is 1 divided by S plus 1 whole square. Please check. So finally what we are getting xt. So we are getting xt as what we are getting xt, it is minus u of minus t, and then we have minus e raised to the power minus t into ut, then we have minus t e raised to the power minus t into ut. I have not written that minus sign at that in previous slide, so we have to write minus sign. We have to write minus sign here. Okay. So finally, if we club together all these things, then minus u of minus t minus ut, we take common, then it is e raised to the power minus t plus t e raised to the power minus t. So this is xt, this is xt. Now let us solve the part C. The part C is xs is given, and the xs is equals to 1 divided by s plus 1 whole square, and the ROC is real part of S is less than minus 1. The ROC is real part of S less than minus 1. So we can see that if we plot the ROC, that plot of ROC is that we have pole at S is equal to 0, and we have pole at S is equal to minus, and basically in fact double pole. So what is the ROC? The ROC is real part of S less than minus 1. So how it will come? When both signals are left sided. When both signals are left sided, so the ROC is real part of S is less than minus 1. It means it should be real part of S less than 0, as well as it should be real part of S less than minus 1, because this is minus 1, this is 0, so the ROC of 0 is this one, and ROC of less than minus 1 is this one. That's why we are getting the common ROC. That's why we are getting the common ROC. So this is common ROC. This is common ROC. So this part, this region, that overlapping region is basically the common ROC. And this is only, and this common ROC is basically real part of s less than -1. So this only possible when we have to satisfy these two conditions. So when we have to satisfy these two conditions, we will get that. So that xs is written as 1 divided by ss plus 1 whole square, and it is equals to xt is equals to, so it is equals to 1 divided by s minus 1 divided by s plus 1 whole square minus 1 divided by s plus 1. So please check that xt is nothing but it is minus of u, because all these are left sided. All these signals, that Laplace transform of the signals Laplace transform, basically this is x1s, x2s and x3s. So x1t, x2t, x3, all these are left sided signal. So the Laplace transform, inverse Laplace transform, is u minus of u of minus t minus e raised to the power minus t u minus t minus t into minus e raised to the power minus t into u of minus t. So what is xt? So xt we are getting, finally xt we are getting is minus 1 plus e raised to the power minus t plus t e raised to the power minus t into u of minus t. So this is our xt, this is our xt, this is our xt. So let us solve the part D of the problem. So what is part D? Actually I forget the problem, so we have to see which one is part D. Okay, so part D is let us see that what is part D. Wait, please wait. So the part D is s divided by s square plus 4 whole square. Okay, this is part D. Let us solve this problem. Let us solve this problem, part D. So part D is xs is given as that is s divided by s square plus 4 whole square, and it is real part of s greater than 0. So it is written as that question is written as, basically the real part of s greater than 0 means it is basically talking about, if we see that we have to apply that one of the property. Okay, real part of s greater than 0 means it is right sided signal. It is right sided signal. First thing is clear that it is right sided signal, and second thing is that let x1t is sine 2t into ut. Let x1t is sine 2t into ut. So what we can do that, what we can do here, we can find out the Laplace transform of sine 2t into ut. First we can find out the Laplace transform of sine 2t into ut. So what should be the Laplace transform of sine 2t into ut? So that Laplace transform of sine 2t into ut is it is 2 divided by s square plus 2 square, and the ROC is real part of s greater than 0, so it is equals to 2 divided by s square plus 4, and the ROC is real part of s greater than 0. Now if we remember that property, that if we multiplied this x1t with t, then t x1t, the Laplace transform is nothing but it is minus d x1s divided by ds. So what is x1s? And the real part of s is always greater than 0. This property will not change the ROC. So what is s1s? x1s is 2 divided by s square plus 4. So dx1s divided by ds is nothing but 2 into minus 1 s square plus 4 into minus 2 into 2s plus 0. So it is equals to minus 4s divided by s square plus 4 whole square. So this dx1s divided by ds. So this is the we can use here. So the Laplace transform of t x1t, the Laplace transform of t x1t is minus d, we can use this value in this part, so it is 4s divided by s square plus 4 whole square. Now what is the question? The question is, in this question we have only s divided by s square plus 4, so we can divide 4 on both sides. So what we are getting, that s divided by s square plus 4 whole square, the inverse Laplace transform is nothing but 1 divided by 4. So inverse Laplace transform is, please check that, please check. So please check that the Laplace transform. So here we can write that. T divided by 4 x1t, the Laplace transform is s divided by s square plus 4 whole square. So in short, we have the inverse Laplace transform of s divided by s square plus 4 whole square. The inverse Laplace transform is 1 divided by 4 is t divided by 4 x1t. And what is x1t? It is nothing but sine 2t into ut. So 1 by 4, so t divided by 4 sine 2t into ut, the Laplace transform is s divided by s square plus 4 whole square. So let us again, I am just going to revise this problem. Okay, so the inverse Laplace transform of this is t sine 2t into ut. Okay, let us revise this problem again. Because this is very important point problem. So let us revise this problem again. Okay, there is some problem, there is some error. Okay, let us do another problem. So the problem is find out the Laplace transform and show that xt convolution with del t is equals to xt. The part B is xt convolution with del dash t is equals to x dash t. So let us solve this problem. So part A is xt, convolution with del t is xt. So this is left hand side and this is right hand side. Let us solve this left hand side first. So let us take the Laplace transform of this left hand side, that is xt convolution with del t, and it is equals to xs multiplied by the Laplace transform of del t is 1, because the convolution in time domain is equals to multiplication in s domain. So we have xs. This is left hand side. Again, if we see the right hand side, then Laplace transform of xt is equals to xs. So here we can see that the left hand side is equals to right hand side. So Laplace transform of left hand side is equals to Laplace transform of right hand side. Again, we have part B, that is xt, convolution with del dash t is x dash t. Again, if we see the left hand side, that is xt, convolution with del dash t, then Laplace transform is xt, convolution with del dash t, and it is equals to xs. And what is the multiplication? Because convolution is converted to multiplication, and the Laplace transform of del dash t is s into 1, so it is s xs. Now if we see the right hand side, so the Laplace transform of x dash t is nothing but xs. The Laplace transform of x dash t is nothing but xs. So we can say that the left hand side is equals to right hand side. We can see that the left hand side is equals to right hand side. Let us solve another problem related to this Laplace transform. The impulse response and input of an LTI system is given as the impulse response is equals to TUT, and the input is given as UT minus 1. Now find out YT. So find YT. So let us solve this problem by using the concept of Laplace transform. So how to find out the solution of this problem using the Laplace transform technique? So first we discuss the LTI system. So what is LTI system basically? So we have a LTI system. So the input is xt and the output is yt, and the impulse response is ht. So if we convert this system into S domain, so the input should be xs and the output and the impulse response is hs and the output is ys. So ys is equals to hs multiplied by xs. Basically that yt, if we see in time domain, what is yt? So yt is nothing but it is equals to xt convolution with ht. So if we take the Laplace transform on both sides, then the convolution in time domain is equals to multiplication in S domain. So it is ys equals to hs into s xs. hs is basically the Laplace transform of ht, and Laplace transform, what is ht? So ht is basically tut. So Laplace transform of this is s square divided by 2. The Laplace transform of this is hs is equals to s square divided by 2. And what is that ROC? So the ROC is real part of s greater than 0. Further we have the input is ut minus 1, the input is ut minus 1. So Laplace transform is minus infinity to plus infinity. Without using the property, it is with using the property, it is we can directly write the Laplace transform, and the Laplace transform is e raised to the power minus s divided by s, but we can prove that. So it is ut minus 1 e raised to the power minus st into dt. So we have excess. The solution is 1 to infinity 1 into e raised to the power minus st into dt, that is e raised to the power minus st divided by minus s. It is 0 to infinity, so it is 1 divided by s multiplied by e raised to the power minus s. So it is e raised to the power minus s divided by s. So this is the Laplace transform of xs, and Laplace transform of hs is already calculated. So it is 1 divided by s square, and both have real part of s greater than 0, real part of s greater than 0. So basically both are right sided signals, Now what is ys? So ys is basically hs multiplied by xs, and it is equals to hs is 1 divided by s square, and xs is e raised to the power minus s divided by s. So it is e raised to the power minus s divided by s cube, and it is equals to ys. So if we see that if we apply the inverse Laplace transform, then yt is basically the inverse Laplace transform of ys, and that is equals to t minus 1 square divided by 2 into ut minus 1. So that yt is nothing but it is equals to t minus 1 whole square divided by 2 ut minus 1. So this is yt, that is time domain of this output yt. Now let us do another problem. So the problem is, assuming zero initial conditions, assuming zero initial conditions, the response yt of the system is given below. So this is us, and this is 1 by s, that is a transfer function, and the output is ys. Now question is find ys assuming zero initial conditions. So find ys. So if the initial conditions are 0, it is assuming that initial conditions are 0, then ys is equals to hs multiplied by xs. And what is hs? So hs is 1 by s, and what is xs? So xs is that xs is ut, here I have taken us. Okay, so sorry for that, it is not us, it is ut. It is ut. Okay, that is impulse function, unit step function. So Laplace transform of ut is 1 by s. Laplace transform of ut is Laplace transform of ut. So basically xt is equals to ut. So Laplace transform of xt is nothing but it is equals to 1 by s. So we have 1 by s multiplied 1 by s, that is equals to ys. So ys is equals to 1 divided by s square, and yt is equals to tut. So this is our answer. This is our final answer. So let us see the problem. Next problem, the unilateral Laplace transform. The unilateral Laplace transform of ft is given as 1 divided by s square plus s plus 1. The unilateral Laplace transform of TFT is TFT. We have to find out the Laplace transform, unilateral Laplace transform of TFT. So Fs is given, that is ft, that is time bounded signal. Then Laplace transform is given as Fs, and it is equals to 1 divided by s square plus s plus 1. It is given. Now what is the Laplace transform of TFT? So TFT, the Laplace transform of TFT is nothing but minus d by ds of Fs. So it is equals to minus d by ds of 1 divided by s square plus s plus 1, and it is equals to 2s. It is equals to 2s plus 1. It is equals to 2s plus 1. Please verify that. It is equals to 2s plus 1 divided by 2s plus 1 divided by s square plus s plus 1. Please verify that. So it is equals to 2s divided by s square plus s plus 1 whole square. So please verify that. So this is Laplace transform of TFT, and that is equals to, so this Laplace transform of TFT, let it is f dash s, and it is equals to 2s divided by s square plus s plus 1 whole square. So please check this. Now next question is, next problem is, if the unit step function if the unit step response of a network is 1 minus e raised to the power minus alpha t, that is provided, the unit step response is provided, then find out the unit, then this unit step response is provided, then find out the unit impulse response, So unit step response, let it is st, let it is denoted by st is given, it is st is equals to 1 minus e raised to the power minus alpha t. Then the impulse response is nothing but the differentiation of this unit step response, that is d by dt of 1 minus e raised to the power minus alpha t, and it is equals to 0 minus alpha plus here it is minus e raised to the power minus sc, so it is alpha e raised to the power minus st. So the impulse response is given as alpha e raised to the power minus st. This is the impulse response. Given the step response, we find out the impulse response. Next problem is If the Laplace transform is given, if the Laplace transform of yt is ys is equals to 1 divided by ss minus 1, then find the final value. Then find out the final value. So let us discuss this problem. This problem is very interesting problem. Why it is very interesting? Because that I will show you why it is very interesting problem, and it is very informative also. So let us solve this problem. So what is final value theorem? So according to let yt has Laplace transform ys, and that is given, and it is given as 1 divided by s minus 1. So what we have denoted that yt is the Laplace transform of ys, and it is provided in the question. Now according to final value theorem, limit t tends to infinity, yt is nothing but limit s tends to 0 s into ys. So it is limit s tends to 0 s into 1 divided by s minus 1. So what we are getting? We are getting 1 divided by 0 minus 1. It is minus 1 we are getting. But this is wrong. This is wrong answer. Why this is wrong answer? Because if we find out the inverse Laplace transform of this signal, then we will get that it is unbounded. So we have to check that signal is bounded or not. Let us discuss this. How it is unbounded? Let us discuss this. So that ys is given as 1 divided by ys is given as 1 divided by ss minus 1, and by using the partial fraction analysis, it is equals to lambda 1 divided by s plus lambda 2 divided by s minus 1. So it is nothing but lambda 1 is nothing but s multiplied by ss minus 1 at s is equals to 0. So what we will get? We will get 1 divided by 0 minus 1. It is minus 1. And lambda 2 is given as s minus 1 into ys at s is equal to plus 1. Then it is s minus 1 divided by 1 divided by s minus 1 at s is equals to 1. The value is obviously it is equals to 1. Now if we write ys, then ys we can write it as minus 1 divided by s, putting the value of lambda 1 and lambda 2. The ys is equals to minus 1 divided by s plus 1 divided by s minus 1. Now what is yt? Just taking the inverse Laplace transform on both sides. So yt is equals to minus ut plus e raised to the power t ut. So this is the Laplace transform we are this is the inverse Laplace transform we are getting. This is the inverse Laplace transform we are getting. Now if we see that plot, we can find out. So yt is nothing but it is the minus t ut plus it is minus t ut plus e raised to the power t ut. If you concentrate on this term, we can find out, we can easily say that if we concentrate on this term, so what we can say that we can say that this signal is unbounded. It is not bounded. If you see that signal is unbounded, e raised to the power t ut. It is unbounded signal. At 0 the value is 1. That final value we are getting, the final value of yt is unbounded. So it is not equals to -1. Okay, it is not equals to -1. It is unbounded. So the answer is unbounded. So my suggestion is to you first draw the graph. You first draw the graph. You first find out whether the signal is bounded or not. Because only applying the formula will not give you the correct result. Because when you have applied the formula for means without considering the fact that the system is that yt is unbounded, without considering that, what we get that this final value is -1, but it is not correct because this is unbounded signal. And if you see that expression also, it is unbounded itself. It is ramp function. It's a negative ramp, although it is negative ramp, but it is unbounded. Okay, so please please check, please do check the means the signal is bounded or not. The signal is bounded or not. Please do check the signal is bounded or not. Let us do another problem related to previous year gate question. So the question is the Laplace transform of it is given as the Laplace transform of it is given as is is equals to 2 divided by s plus 1, and as t tends to infinity, the value of it is, we need to find out the final value. So limit t tends to infinity, it is nothing but limit s tends to 0, s into is. So first step 1. First step, we find out whether it is bounded or not. So first step, find whether it is bounded or not. So, and if it is bounded, next step 2, if it is bounded, then find Laplace transform. So let us start that. So that is given. So is given as 2 divided by s plus 1. So it is equals to lambda 1 divided by s plus lambda t divided by s plus 1. And lambda 1 is equals to s divided by 2 ss plus 1 at s is equals to 0. It is equals to 2 divided by 0 plus 1, it is 2. And lambda 2 is s plus 1 multiplied by 2 ss plus 2 at s is equal to -2. So it is equals to -1. 2 divided by -2 is -1. So is is nothing but it is equals to 2 divided by s minus 1 divided by s plus 1. So it is 2ut minus e raised to the power minus t into ut. So it is bounded. It is bounded. So we can apply the final value theorem. Since it is bounded, so we can apply the bounded. Since it is bounded, we can apply final value. So the final value is limit t tends to infinity, it is nothing but limit s tends to 0, s into is, that is limit s tends to 0, s into 2 divided by s plus 1, so it is equal to 2 divided by 0 plus 1, that is equal to 2. So the answer is so the final value, the answer is 2. The answer is 2. So